Billy bought 2 pizzas. He ate 3/4 of one because he couldn't finish one. Wuss bag. How much pizza does he have left? Okay, well, here's the thing: is a pizza. He's got 2 pizzas to start out with. So there's my 2 pizzas. Okay. Now it says he's gonna eat. That's subtraction. Is 3/4 of one of them. So we're gonna subtract 3/4. Okay. Then how much pizzas does he have left? That's what this will equal in the end. So I'm going to make this 2/1 and scale that fraction. The second part of this is going to stay the same, right? So I just got to scale the 2/1. That will give me a new fraction because I know that everything is a multiple of 1. So 1 times 4 there in the denominator will be a matching denominator 4. But I got to do the same thing to the numerator. 2 times 4 is 8. 8/4 is 2. Yes, it is. And now I'm ready to combine my 2 numerators because the denominator stays the same as 4. So that's 8 minus 3. Try to match these colors. So in fourths, what is this? In fourths, well, 8 minus 3 is 5. Now the answer is not 5/4, by the way, although you may have thought it was. This is a word problem, so make sure you label this one. I'm going to say it's in pizzas. And that's good enough. All right, there's our objective for 3.1. I can force denominators to match so that I can add and subtract fractions. Hopefully we're feeling pretty good about that. All right, here's this bell work 2/5 plus 6. So I'm going to make that 6/1 and just scale it. Okay, so that it forces the denominators to match. Of course, it's not going to affect the 2/5 because I can just multiply the 1 by 5 to force that denominator to be a 5 as well. It's just if I do that, I got to do it to the numerator as well. 6 times 5 is 30. And then I get 2/5 plus 30/5. And then finally here, since the denominators match, all we need to do is add the numerators 2 and 30, which is going to give us, in the end, still in fifths, but 2 plus 30 is going to be 32. So 32/5 would be the fraction, and that cannot be simplified, so that's it. Let's go on here to 3.2. Here's 2 objectives for us. I can divide with fractions, and multiplication is built into the second objective because we don't actually end up dividing with fractions. We only multiply, so I know how to change division with fractions into multiplication, and then we operate from there. Take 1 minute, copy this down. Multiplying fractions. Now this is a very complicated way to say this, but all you're doing is multiplying the numerators to get a new numerator, and then you're going to multiply the denominators to get a new denominator. That's it. Unlike addition and subtraction of fractions, we do not, that's what it's saying down here, we do not need common denominators in order to multiply with fractions. Please remember that because it's very common for students to do that in multiplication and division of fractions, okay? So we're going to multiply these out, and then in the end, of course, we'll always check to see if it can be simplified. Like this one right here. Now, this one of the fractions is negative, and that's okay. Since one of the fractions is negative, I know my answer will be a negative. But remember, you're just multiplying the 2 numerators. 5 times 7, which is 35. That's my new numerator. And then 4 times 10 in the denominator, boom, 40. Okay? So I get negative 35/40ths. And the last thing I should do here is to check to see if this can be simplified. It can. How do I know that it can? Well, if you look at 35 and 40, you got a 5 in the ones and then a 0 in the ones, which means that both of these are divisible by 5. Okay, so I'm going to divide both of them by 5, which scales this fraction down. It does not change the value. It only changes the way it looks. 35 divided by 5 is 7. And then 40 divided by 5 is 8. So I end up with negative 7/8. That is fully simplified because I know 7 is prime and 8 is not divisible by 7. So that's done. All right, so always look for that simplification process at the end if you can. If it can't be simplified, then just leave it. All right. So once again, if you were to type this into Canvas, though, remember it's the 7 numerator that we want to show as negative. So we would type it in as negative 7 divided by, that's the slash button, and then 8. That's how you enter this into Canvas. All right, how about this problem? Yep, we can do this one too. So both these are positive. That's great. So I'm going to get a new fraction here, but I'm going to multiply the numerators. 2 times 3 is 6. And then in the denominators, 5 times 9 is 45, okay? Now we're looking to see if this can be simplified. And I know that 6 is divisible by not just 6, but 2 and 3, okay? 2 and 3. I know 45 is not divisible by 2 because of the 5 in the ones place by. It has to be even, but it's odd, so I know it's not divisible by 2. It is divisible by 3, but how do we know that? Well, all you got to do is take the two numbers, 4 and 5, the two digits, and instead of looking them at place value, just look at them at regular numbers. 4 plus 5 is 9. And since 9 is divisible by 3, that means 45 is also divisible by 3. We already knew that 6 was divisible by 3. So what does this give us? In the numerator, 6 divided by 3 is 2. And in the denominator, well, I'll have to do some long division here, but 45 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtract, get 1 left over. Drop your 5. 3 goes into 15. 5 times 15. Nothing remaining. And so we're left with 45 divided by 3, which is the quotient there of 15. That is fully simplified. Now, there's something that we call cross simplification of fractions, not cross multiplication. Do not get the two confused. This is cross simplification, very different, okay? What this allows us to do is to take values from the numerator and denominators, and if they are simplifiable together, no matter where they're placed, then we can simplify. So like we see in this example here, this b could be simplified with that b, and you could say, look, we're just going to cross these out. Okay, now be careful because some people say they cancel out. Well, it's important to know what cancel out means. It means that that becomes a phantom 1. So there's a multiply by 1 there. We don't want to see that because then it's not fully simplified, okay? By the way, that multiplication by 1 is still there. We just can't see it. Okay, it's lurking in the shadows. Remember those phantom values? But it doesn't matter if it's diagonal that way or if it's diagonal this way. Again, you still have that phantom multiplied by 1, but don't show it so that it's considered fully simplified, okay? Of course, we know that it's possible to simplify straight up and down if you need to, all right? So if we look at that previous problem, this problem right here, okay? So some of you may have even noticed that the 3 and the 9, yeah, that they're both simplifiable by 3. You say 3 divided by 3 is 1, so we replace the 3 with 1. And then 9 divided by 3 is 3, okay? And then you would have just did, well, 2 times 1 is 2, and then 5 times 3 is 15. And then you would have gotten the 2/15 a little bit earlier. Now, all this means is that when you simplify is up to you. If you want to simplify before you start to multiply, that's fine. But if you want to do it like we did that last problem and then simplify at the end, that's fine too. It's usually split pretty evenly between students. Some prefer to simplify in the beginning. Some prefer to simplify in the end. It's completely up to you, all right? And one last thing on cross simplification here is that whether you like this cross simplification method or not, it's coming back. I mean, not until like 10th grade, but it's coming back, okay? So if you can learn to simplify fractions right now, then in the future, when you see that there's a need for cross simplification, hopefully it will help you to make a little bit more sense out of that, okay? So here we go. I'm going to be using cross simplification. So on this one, is there any numerators and denominators really that match or can be divided by the same value? Yeah, there's the 5s right there. 5 divided by 5 is 1. 5 divided by 5 is 1. Okay, now I am ready to multiply to get my final fraction. And in fact, there's a negative right there. There's a negative and positive. They're opposite signs, so I know my answer is negative. Now, before I move on, some of you noticed as well that the 2 and 4 are both divisible by 2. Feel free to simplify those. 2 divided by 2 is 1. 4 divided by 2 is 2. See how I cross-simplified right there in both directions? Yeah, that's okay. In the numerator, I now have 1 times 1, which is 1. In the denominator, I got 2 times 1, which is 2. So, in the end, that multiplication simplifies into negative 1/2. Now, could you just have multiplied those to make that negative 10 over negative 10 over 20? Yes, you could have. And then you would have simplified them by dividing both by 10. Yes, that would be fine. Okay? But I use cross simplification, which is my preferred method. Not only because it makes the multiplication a little bit easier, which it does. It's easier to multiply with smaller numbers here than it is with bigger numbers. But again, it's also because you're going to be using this in the future, 9th or 10th grade, something like that. All right, how about this problem? So we got some pretty big numbers. And again, you could just multiply these out if you'd like, but I'd like to multiply with smaller numbers. Just make things a lot easier for me. I see, and I'll do this one a little bit differently, but the 47 and the 7 right here. I know the 47 is a multiple of 7. So instead of just crossing these out, I'm going to show the work here. So I'm going to take 42 and divide that by 7, okay? Well, I also take 7 and divide it by 7. Remember, whatever you do to the numerator or denominator, you got to do the other one. So that would give me, and in fact, I'm going to need more space here, but 42 divided by 7 is 6, and then 7 divided by 7 is 1. All right, maybe at this point, that's where you want to cross those out to make your phantom 1. Okay, and that's nice, it's pretty, and it makes the 42 a lot smaller into a 6. However, hopefully you will notice that this 6 is divisible by 3 because the 3 is definitely divisible by 3, okay? Which now 6 divided by 3 in that numerator gives you 2. So again, that kind of went away. And 3 divided by 3 is 1, okay? So we cross-simplified diagonally first, and then we cross-simplified vertically. Yeah, that's okay. And what do we get in the end here? Well, still going to get a fraction. Oh, there's only one negative there, so it's going to be a negative fraction. Now I'm going to take my 2 times 8. 2 times 8 is 16. That's my numerator. In the denominator, 1 times 1 is 1. Now, negative 16 over 1, hey, that's pretty good, okay? However, in the homework, if you type that in, it's going to be incorrect. Make it fully simplified by making that one denominator phantom 1. Just make it negative 16. That would be considered fully simplified. So, reciprocals. Now, the word reciprocal is a pretty nerdy word, which is why we learn it in math class. But if you hear the word reciprocal, just know that it's talking about flipping the fraction, okay? So when you say take the reciprocal of a fraction, that means just flip the fraction. There we go. All right. That's all it means, all right? Now, why do we got to flip the fractions? It's because we never actually divide with fractions. We only multiply. But in order to change a division problem with fractions into multiplication, the only way we can do that is by reciprocating the second fraction, also known, what we talked about in Unit 1. That's called the divisor, okay? So you can see on this fraction right here, these would be numbers, right? But the top becomes the bottom becomes the top, and it can go both directions, okay? But we're going to need to know how to reciprocate or flip these fractions in order to multiply or divide with fractions, okay? So here, let's look at these 3 examples, and we got to be able to reciprocate or flip them, right? So 5/3, still going to be a fraction, but the 3 in the bottom will be the top, and the 5 in the top will be the bottom. 3/5. That is reciprocated. I'll do the same thing with 4/5. Let's go ahead and reciprocate this. 5 in the denominator becomes the numerator. The 4 in the numerator becomes the denominator. There we go, flipped. Okay. Well, what do we do about 12? Hey, remember, just make it 12 over 1. Now it is a fraction that can be flipped. That divide by 1 was always there, by the way. And now I get, finally, a 1/12. It's flipped. Okay? So the reciprocal of 5/3 is 3/5. The reciprocal of 4/5 is 5/4. And the reciprocal of 12 is 1/12. So here's why we need those reciprocals. Because the divisor, the second fraction in a division problem, will always be flipped in order to change that into multiplication. All right? So again, see how the AB, the first fraction, it stays the same. It's still structured that way. So if it was, I don't know, like 1/2 right here, it would stay, well, 1/2 right there. Okay? The dividend, that's the dividend part of the division problem. Again, that goes back to Unit 1, but it's stuff that we should be able to do. Okay, we should know this vocabulary because what we're seeing again. But notice again that this numerator became the denominator became the numerator, but the operation changed from division to multiplication. That's the idea. We never divide with fractions. We always change it into multiplication. I was told by one of the other students that this in elementary was referred to as keep, change, flip, which sounds a lot like keep, change, and that's fine that it does as long as you don't get the two mixed up, okay? Keep, change, flip, it works in order to change division problems into multiplication. Just remember in the end that you should always simplify the answers if you can. Since it would be nice, and I would really like you guys to get used to cross simplification. That's what I'm going to focus on with these problems as we change them from division into multiplication. Like this one, okay? Now, most people usually hate fractions as is, but when we start dividing them, yeah, it's like, oh man, this freaking sucks. But if you just change this to multiplication, you'll see that it's not so bad, okay? And right off the bat, I can see that there's two negatives in this, so my answer is just going to be a positive. I don't need to worry about the negative signs, okay? However, I do not want that division there. I want to change that into multiplication. It's just if I do that, my 6 over negative 7 will have to flip to negative 7 over 6. I know we said the answer is positive, but I'll keep that negative just to show a little bit of extra work. So that's a negative 13 over 5th. 5 times negative 7 sixths. Again, we know the answer here will be positive, but 13 times 7. I don't see any cross simplification here, by the way, but 13 times 7. Let's go and do that. 13 times 7. 7 times 3 is 21. Carry the 2. 7 times 1 is 7, but add the 2 is 9. So 91. That's my new numerator. And in the denominator, 5 times 6 is 30. Okay, now, some of you may think that 91 is divisible by 3, but 9 plus 1 is 10, which is not divisible by 3, so this one's done. And please do not change these into mixed numbers. We want the improper fractions in a pure math setting like we are in. Here's more division. So we don't want division though. We only want multiplication. So that's what I'm going to do. I'm going to change the division to multiplication. Just if I do that, I got to reciprocate that second fraction. Flip it into 3/2. Then you got 5/4 times 3/2, okay? And now that it is multiplication, and they're both positive, so I know my answer is going to be positive. I don't see any cross simplification, so I'm going to go straight into the multiplication. 5 times 3 is 15 in the numerator. In the denominator, 4 times 2 is 8. 15/8 cannot be simplified. It is done. All right. So negative 13/7 divided by 4/3. Yeah, no division of fractions, only multiplication. It's just if we do that, make sure you reciprocate the second fraction, known as the divisor. That first fraction just stays the same, negative 13/7. Okay? Now, I don't see any simplification that can happen, and we've only got one negative, so the answer is a negative. You can say it's a negative and a positive, same thing. But in any case, I'll start with 13 times 3. So let's go and do that. 13 times 3. 3 times 3 is 9. 3 times 1 is 3. 39. That's my new numerator. And in the denominator, 7 times 4 is 28. If this could have been simplified, we would have done it back here, but I don't see that it can, even in the end. And you should always check even in the end that it can, just in case you miss some cross simplification. So that's just done. Remember, if you ever see whole numbers, just write them over 1. That will give you a fraction to work with other fractions, no matter what the operation is, whether it's addition, subtraction, multiplication, or division. So once again, just like we saw in the last section, if you saw the number, I don't know, 15, or even negative 15, just make it over 1, okay? That phantom divided by 1 is always there, lurking in the shadows, waiting. So here we got 3 times negative 1/5. Make this a little bigger, and it's already multiplication, so I'm going to make this 3 over 1, right? Now I can multiply the numerators. 3 times negative 1 would be negative 3. Then I'll multiply the denominators. 1 times 5 is 5. I end up with negative 3/5. Done. And again, if it could be simplified, you would. Some of you may have been thinking, can't we simplify those ones? I mean, sure, but 1 divided by 1 is just 1, so it's kind of built into it. All right, what about this division problem? Well, remember, we don't want division. However, since we're going to change this into multiplication, which we will do, we need to see that this is 4 over 1. Okay, because I will also need to reciprocate it into 1/4. The negative 2/7, yeah, that's okay. Oh, here we go. This one does have some cross simplification, so that's what I will do. I see the 2 and 4, they're both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Now this is going to make the multiplication much easier. I know the answer will be a negative because there was only one negative. But in the numerator, 1 times 1 is 1. In the denominator, 7 times 2 is 14. Negative 1/14. That is considered fully simplified. Done. So I know I'm going through those kind of fast, but that's because I want you guys to have enough time to do at least some of the homework in class. Okay, but here's a nice word problem for us. The teacher bought 30 muffins for her class. A group of students snuck in and ate 3/5 of them, stinking jerks. How many muffins did they eat? Okay, so this one's different than the problem that we saw in 3.1. We're certainly going to start with 30 muffins, and that's okay. We're going to take these 30 muffins. What are we going to do with them? Well, we want to know how many muffins they ate. Now, this is not eating 3/5 of a muffin. If it was 3/5 of a muffin, then you would subtract 3/5. But it's saying it's eating 3/5 of the muffin. So it is 3/5. It's just the of word makes this a multiplication problem, okay? Once I multiply these out, then I will know how many muffins the stinking students ate. So I'm going to make that 30 over 1. And I can cross simplify the 30 and 5 right there. Both of them are divisible by 5. 30 divided by 5 is 6. 5 divided by 5 is 1. And now when I go to multiply these, I got 6 times 3, which is 18 in the numerator. And in the denominator, 1 times 1 is 1. Now you could say you got 18 ones. But again, if you see that, make sure you simplify that fully into just an 18. I don't think that was a lot of work, but the answer is not 18. Okay, there's a word problem. You got to make sure you label these. What were they? Muffins. Muffins. All right, so the final answer is 18 muffins, not just 18. How about this one? Your mom buys 7 pizzas for a party. If every person gets 1/5 of a pizza, how many people can eat the pizza? All right, well, as long as everyone gets the same amount, right? And since we are assuming that everyone gets the 1/5, it's the same amount, we're splitting this up. That's what this is doing. It's going to split up the pizza. That's a division problem, okay? So we know we're going to divide. It's just what are we going to divide? 7 pizzas, that's what we're going to divide. Okay, so that's our divisor. How much are we dividing it up by? Fifths. So it's 7 divided by 1/5, okay? Now you're welcome to show that as 7 over 1. Just please do not multiply, do not divide. Make this multiplication. So now you got 7 over 1. But we've got to reciprocate that 1/5 right there, right? To make it 5 over 1. So multiplying this out, we'll still show it as a fraction first, but 7 times 5 is 35 in the numerator. 1 times 1 in the denominator is 1. And just make this 35. Okay. But once again, the answer is not 35. It's a word problem, so we got to label it. It's probably going to be pizzas or people, but the question says how many people, so we know that the final answer here will have a label of people. 35 people can be fed as long as everyone gets 1/5 of a pizza with 7 pizzas. And 1/5 of a pizza, just got to tell you, that's a pretty disappointing, you know. Should be like a full pizza. What the heck? There's our objective. I can divide with fractions again. You should have to be able, you will always change division of fractions into multiplication. So it's kind of built into that objective too. But I know how to change division with fractions into multiplication. That's crucial because we never actually divide with fractions. We only multiply.